Okay, hey everyone, we're starting our section here on solving systems by elimination. This is our third and final method of doing this. So as we go through, this will round out kind of how we're going to solve systems. So we've looked in the past already so far at graphing systems of equations. Remember that we graphed the lines very carefully and then found the point of intersection, and then we checked it to make sure our graphing was right. So we did that. Yesterday, we looked at solving systems by substitution. If you remember that from yesterday, we basically just took part of one equation and inserted it into the corresponding part of the second equation and then solved for our remaining variable, and then went back, plugged it in, and got our other value. And then remember, your solutions are written as ordered pairs, your x value first along with your y value second. So that's kind of where we've been. Where we're headed now is we're going to have two videos here today. This first one, they're both dealing with elimination. The first one is kind of the basic version of it, and the second one we have to do a little more work to get where we want to go. But you're doing the same process, the same math in both of these videos. So just kind of hang with us here. Make sure you're taking good notes and not only writing down what's on the screen, but writing down kind of what I say as well. So let's move forward. So solving systems by elimination, we said that each method really lent itself to certain situations. Graphing when you were told to graph it. Substitution was great when one of your equations was solved for a variable. Elimination is very useful when equations are in standard form. And notice I have that standard form in quotation marks. We don't really have to follow the rules of standard form, more just that your variables line up. Okay, so that's kind of what we're looking for here. This first part, you just want your variables lining up. You're not going to have it a perfect standard form. We don't have to go through all those rules of standard form. We just got to make sure that the x's are over the x's, the y's are over the y's, and your constants are over your constants. And we'll see what I mean by that in a second. It'll look like standard form, but we don't have to worry about the rules in that. So a couple things. We want to add or subtract your equations together, and that will, in hope, eliminate one of your variables. So either x will cancel out, so to speak, or y will cancel out. That's what we want, because then we have an equation left over that only has one variable in it. So that's what we're going to have. We'll solve for that variable, then we'll go back and find the value of the other one. So that process, once we find that variable, is very similar, but we'll go from there. So let's start with this first example here on the left. 3x plus 2y equals 8, and negative 5x minus 2y is equal to 4. So what we want to look for, we said you want to kind of add or subtract equations to eliminate. Well, in order to eliminate, we need coefficients that are the same. So that's another kind of added piece here. If I put a 3 in here, you're looking for matching coefficients. Matching or opposite is another one we could say, because that's fine. Coefficients. Our coefficients are just the numbers that are represented in front of the variable. So if I look at here, this first one, my x values. Well, x is over x, y is over y, and constant is over constant. So that's good, but my x's aren't matching. One's a 3, one's a negative 5. So those aren't matching, neither the opposite. Look at my y values. Well, I have a 2y here and a negative 2y here. Well, that's what I want. That's that opposite idea here. So I have that, so I can simply go forward now and add, because I have opposite. I want something that's going to cancel things out. So I'm going to add these two together and simply add down my terms. So I have a 3x plus negative 5x. That gives me a negative 2x. All right, well, 2y plus negative 2y, well, that just cancels out. That's what I want. It's called elimination for a reason. It eliminates a variable. And bring down your equal sign. And then I have 8 plus 4. That gives me 12. So if I look now, I have a real simple problem where I have one variable. I can solve that. We all know how to do that from here. Divide both sides by negative 2. So x will equal negative 6. Cool. I have a value for x. Okay, well, once I have a value for x, I can go back to one of my original problems. It does not matter which problem, but if we work that idea of smarter, not harder than we need to, I want to get y. I'm going to use the first one because it's positive. So we have 3, I believe it was 3. Yep. So 3 times my x value, which was negative 6, plus 2y will equal 8. Okay, and we simply solve. Well, 3 times negative 6, that's a negative 18. So I'm plus 2y equals 8. I'm going to go ahead and add the 18 to both sides to continue solving. So I will get 2y equals 26. Divide both sides by 2. So y will be a total of 13. So now I have an x value, I have a y value. So my solution, remember, is the ordered pair that combines those two. X was negative 6, y was 13. And that gives me the answer. Remember, we have the Desmos graphing calculator we can use to check our work, and we'll be able to see that and go from there. So we have our solution. That's solving by addition. Now let's come over here to the next example. Okay, same idea. Okay, take a second, copy it down. Okay, put it on pause for a second and copy it down so we have it ready to go. Okay. Our example now, we have x's over x's, y's over y's, and constants over constants. That's great. That's what I want. Okay, again, looking for matching or opposite coefficients. Well, again, x and x. Well, I have a 1 and a 6. Those don't match, and are opposite. My y's match up completely. I have a negative 4 and a negative 4. That's great. So that's what I'm going to look to eliminate. So we'll draw my line here. Now the difference here is instead of adding, because if I added these together, I would get 7x and I would get negative 8y. Those don't cancel out. So adding these won't work. But if I come out here and subtract, check out what happens. I have 1x minus 6. That's negative 5x. I have negative 4 minus negative 4. Negative 4 minus negative 4 is like negative 4 plus 4. So those cancel each other out. Okay. Then over here, 7 minus negative 8, that becomes addition. You get a positive 15. So we're great so far. Just like before, my variables canceled out. So divide both sides by negative 5 to get my values. So x will be a total of negative 3. Great, great, great. Have half my answer. Let's go back and plug it in to find your other answer. It doesn't really matter which problem you're doing this one. I'll plug it into the top because x is just simple there. So I have negative 3 minus 4y will equal 7. Okay. So I'm going to add, that was 7, wasn't it? Yep. I'm going to add 3 to both sides. So it was negative 3. So I will get negative 4y equals 10. Moving forward, divide both sides by negative 4. Okay, it's not an even number, it's not a whole number, but it's still going to be an answer. It's a fraction, not a big deal. Right? If I reduce that down, they both are divisible by 2, so I'll have a negative 5 over 2 for my y value. So again, my solution, your x value first, negative 3, your y value second, negative 5 over 2. And that, my friends, is our solution. Okay. So there's that first video on solving these guys. One you add in, the other you subtract. And if you look at when I added and when I subtracted, I added when my coefficients were opposite. So this is a good thing to write down. So for those of you that aren't using your headphones, you're going to miss out on this. For adding, again, we add when our coefficients are opposite. So plus 2 and negative 2. Those are opposite, so we add. Okay. Over here, they were matching, negative 4, negative 4. We subtract those. So as you look, when they're the same, you subtract. When they're opposite, you add. And that will take us through to the end of that. So there's the first video. The next video is very similar, except we have to work the problem a little more to get to where we want to go.